Hello students, let us continue our lesson, force and interaction. Definition of interaction. If a body A exerts a force on body B, we have two bodies, body A and body B. If a body A exerts a force on body B, this force is F of A on B. Simultaneously, body B acts a force on body A, F of B on A. Okay. If a body A exerts a force on body B, simultaneously body B acts a force on body A at the same time. The characteristics of these two forces are: these two forces have same line of action, opposite direction, and same magnitude. Okay, the characteristics: the two forces are on the same line of action, opposite direction, force to the right and force to the left, and same magnitude, same value. The expression here, we can use it and replace this statement. How? F of A on B plus F of B on A equal to 0 vector. Now, if we move F of B on A to the right, then we have minus. Minus means opposite direction. F of A on B equal minus F of B on A. Minus means opposite direction. Now, what about the values and magnitudes? The magnitudes are equal. The forces without vectors, we mean the magnitudes. Okay? Okay. Now, the interaction has two types: contact interaction or acting from a distance. If the two bodies are in contact with each other, we call this interaction contact interaction. But if there is a distance between the two bodies, the interaction is called acting from a distance. Example: box and the table. The box has symbol B, the table has symbol T. The interaction is between the box and the table. This interaction is contact interaction. Box and table, they are in contact with each other. We represent the force of box on table by the following representation: F of B on table and F of table on B. So the condition is F of box on table plus F of table on box equal to 0 vector. Other example is the following: nail and the magnet. Look, there is a distance between them. The interaction between the nail and the magnet is acting from a distance. The forces are the force of nail on magnet and the force of magnet on nail. The condition is the force of nail on magnet plus F of magnet on nail equal to 0 vector. Okay, this is the interaction. Now, let us talk about the resultant of two forces. If the forces are collinear, back to the forces, if we have any forces and they are collinear on the same line, as here, F1 and F2 to the right, F1 and F2 both to the left, how can we find the magnitude of the resultant force? F resultant equal F1 plus F2. Example: F1 equal 5 Newton, F2 equal 2 Newton. F resultant equal summation of F1 plus F2. So Fr equal 5 plus 2 equals 7 Newton. Note, what about the direction of the resultant force? F resultant has the same direction as F1 or F2 in this case. Okay? F1 and F2 have same direction, so the F resultant also has the same direction. Now, if the forces have opposite direction, how can we find the resultant force and the magnitude of the resultant force and the direction of the resultant force? Example, F1 is to the left and F2 to the right. But in this example, F2 is greater than F1. So F resultant equal the greater minus the smaller. F2 minus F1. Example, if F1 equal 2 Newton and F2 equal 3 Newton, then Fr equal F2 minus F1. The greater F2. The smaller is F1. So F resultant equal 3 minus 2 equal 1 Newton. But what about the direction of resultant force? Resultant force has the direction of the greater one. So F2 is greater than F1. Look, Fr is in the direction of F2. Fr has direction as F2. Okay, thank you, good luck, see you later.